Hi. Now let's discuss about the major historical moments in the field of AI. Gestation of AI. In 1943, Warren McCulloch and Walter Pitts drew on three sources. 1. Knowledge of basic physiology and function of neurons. 2. A formal analysis of propositional logic. 3. Turing's theory of computation to propose a model of artificial neurons for the first time. They showed that any computable function could be computed by some network of connected neurons. In 1949, Donald Webb demonstrated an update rule for modifying connection strengths between neurons. His rule, Hebbian learning, remains an influential model till today. In 1950, two Harvard undergrad students, Marvin Minsky and Dean Edmonds, built the first neural network computer called SNARK. It used 3,000 vacuum tubes and a surplus automatic pilot mechanism from a B-24 bomber to simulate a network of just 40 neurons. In 1950, Alan Turing published the famous Computing Machinery and Intelligence paper. I would recommend everyone to read this paper as it introduced many important concepts like Turing test, machine learning, genetic learning, and reinforcement learning. He also proposed child program idea, where we will try to simulate a child brain instead of an adult. Birth of AI. In 1956, John McCarthy, a Princeton professor, along with other influential researchers like Marvin Minsky, Claude Shannon, and Nathaniel Rochester, organized a 2-month summer workshop where AI was first coined. The idea behind the workshop was that every aspect of learning or any other form of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. It was an early attempt to make machines use language or form concepts and abstracts, and also solve problems that were once only reserved for humans. This has led to an early enthusiasm with great expectations. In 1958, John McCarthy invented Lisp language at MIT AI Lab, which was used as the preferred language for AI programming for the next 30 years. Later in the same year, John McCarthy also invented Advice Taker. This was considered as the first complete AI system that can deduce logical conclusions based on common sense reasonings just like a human would do. In 1959, Newell and Simon has developed General Problem Solver, which is also known as GPS in short, that can solve problems with the same reasoning steps as a human brain would solve. GPS was probably the first program to embody the thinking humanly approach. However, these great expectations met a roadblock. They call it the AI winter. AI winter is referred to as a sudden decline in funding and research interest in the field. In 1966, most of the researchers overestimated the possibilities of AI and they created a hype around the problems that can be solved using AI. So there was a failed attempt to solve machine translation of scientific papers from Russian to English. And this has led the US National Research Council to cancel funds for academic translation project. Also, when AI programs were attempting to solve problems in higher dimensions, the theory seems to fail as it was computationally expensive to find solutions in higher dimensions. This also was a contributor to the gloom of the AI. In 1973, there was a Lighthill report that said AI research has failed to come to grips with the combinatorial explosion. This was a major reason behind the decision by British government to end support for AI research. However, knowledge-based systems started to have an impact compared to the problem-solving algorithms that were seen in the first decade of AI research, where problem-solving algorithms was more of a general-purpose search mechanism trying to just stitch reasoning steps to find complete solutions. The problem with such approaches was they were weak and they did not scale to larger or difficult problem instances. So the alternative to such problem-solving approaches was to use more powerful domain-specific knowledge that allows larger reasoning steps in smaller time frame. So in such a vein of thought, in 1976, a Stanford group has invented Mycene, a knowledge-based expert system to diagnose blood infections. It was in fact performing better than most physicians. An expert system is one where the inference rules are collected from a group of experts who are physicians in this example, and these inference rules are encoded as a knowledge based system that a computer can make inferences from. For example, if you take any weather forecasting system, if it looks at humidity less than 80, then the rule can be that to predict it is going to rain. Or if the humidity is greater than 82, then you predict there's going to be no rain. Such are the examples of an expert system. In 1972, Prolog was invented. These logic-based knowledge systems were in high demand as many applications were solving real-world problems. And the Prolog invention also contributed to this growth as it was heavily used for building such expert systems. So with these real-world applications, AI has created an industry for itself. One good example is in 1982, Digital Equipments Corporation (DEC) implemented an expert system called R1 to configure orders for new computer systems. By 1986, it was estimated that it saved up to $40 million for the company. Soon, the AI industry boomed from a few $1 million in 1980 to billions of dollars by 1988. A lot of companies started building expert systems, vision systems, robots, software and hardware specialized for these purposes. Soon, there was a second AI winter. An industry grew up to support them. There were specialized computers built called Lisp machines that are using the Lisp programming language to build expert systems. So these specialized machines were proved to be too costly to purchase when compared to cheaper general purpose machines that were introduced back then by companies like Sun, IBM, and Apple. Also in the early 1990s, expert systems proved too expensive to maintain. They were difficult to update. They could not learn to new instances. And they were making very grossly simple mistakes when given unusual inputs. Expert systems proved useful, but only in a few special contexts. This resulted in a second AI winter when companies failed to deliver on their extravagant AI promises, and again, the funding and research efforts has witnessed a steep decline. However, there were few research groups attempting to solve the learning problem in neural networks, and they found a success in the invention of backpropagation in the mid-1980s. Backpropagation is heavily used even today in training neural networks. The emergence of intelligent agents happened after internet has arrived. Machine learning started playing a key role since early 1990s in building efficient internal tools like search engines, recommender systems, fraud detection, spam classifiers, and others. Emergence of machine learning has addressed the problem of knowledge bottleneck in AI. Compared to earlier expert system models, the problem of expressing all the knowledge that a system needs in the form of hand-coded rules can now be replaced by learning methods, provided the learning algorithms have enough data to work with. Till 2000, the research in AI were mainly focusing on improving the algorithms as a key area of research. However, with the internet, social media, and smartphone revolution has resulted in a huge influx of data. And then there were research like Banco and Brill in 2001 showed that mediocre algorithms with 100 million samples was able to outperform best known algorithms which were trained only on 1 million samples. So it all started to make more sense to worry about the data and be less picky about the algorithm to apply. However, this big data was proving to be a computational bottleneck to train state-of-the-art models with the existing CPU hardware. In 2012, Jeff Hinton's group has showed that GPUs can be used in significantly reducing the training time of algorithms, which can then work on large amounts of data to achieve state-of-the-art results. In the next segment, we'll be introducing agents, its key terms, and components. Thank you.